Hi, I'm Karriem Lateef, and I am a pre-sales technical resource in Microsoft Federal with responsibilities around what we call our data platform. So that's going to be SQL Server, BizTalk, and then any of the data platform components in Azure. So Azure SQL Database, Azure SQL Data Warehouse, Internet of Things, Power BI, anything that really deals with data and analytics falls into my wheelhouse. And I'm actually subbing for Ted Malone, who built the demo that I'm going to be showing you later on. But Ted's on my team, and we work together closely. So to start, we're going to talk about, actually, I'm going to blow through the analytics revolution, and we're primarily going to talk about the journey from data and information to knowledge and wisdom, why you care, and then generally talk about the real-world application, which was the White House call to action around traffic fatalities. So the real idea behind this slide is that the current big data revolution isn't all that unprecedented. We've lived through three revolutions so far, from the Industrial Revolution, where we moved from sailboats to steam engines. The second Industrial Revolution was from moving from actually handwritten letters to the telegram. The third Industrial Revolution moved us to computers, and one big example of a company that didn't necessarily adapt with the times is Kodak. You know, if you look at the transition from film to digital pictures, Kodak was really slow to realize how revolutionary that would be. Fuji tended to take advantage of that and adapted their business accordingly, but Kodak was slow to adapt, and as a result, they're pretty much obsolete at this point. Well, not obsolete, they're just not really a factor as you move forward and think about digital cameras and things of that sort. And the fourth Industrial Revolution is really the move of big data, the cloud. You can't see this. This is big data, the cloud, and intelligence. So when we look at the paradigm, the move from data to wisdom, you know, initially you're going to start with the data. When you move to the information stage, it's more, what is the data? What do we have in the data? What actually happened? When you move to the knowledge stage, you're talking about, why did that happen? You know, so as you move up the paradigm. And then when you get to the wisdom stage, you're doing that predictive analytics when you're talking about not only why did that happen, but what will happen next? What will happen given these criteria? What will happen given these factors? And that's where you really get into the advanced analytics space. With our traditional tools, you can figure out what happened and kind of why it happened. That's pretty traditional analytics. But when you're moving and enabling machines to ascertain context and understanding, that's when you're really getting into the special sauce and getting to the wisdom piece of it. So if we look at a data science project, you kind of start with a plan. What's the question I'm trying to answer, and what's the data I need? Your next step is you're going to try and acquire the data, and then you're going to try and cleanse the data. You're going to look at the data quality, you're going to reformat, you're going to impute, etc. You might add new measures. And your next step is where you're going to analyze that data. So once you've cleaned it, once you've loaded it, cleansed it, you think the data's you think you've got a clean data set to work with, then you're going to start some analysis. And this is more of an iterative process because, you know, as you start analyzing that data, you're going to realize the questions you want to answer might not be able to be answered in the format that you have it. So you're going to create more features. You're going to then create a model. You're going to evaluate the results. And then you're going to iterate through this a bunch of times. You know, this isn't a static process. You're continually improving on your model. Once you feel like you've got your model in a good state and you've evaluated the results, you can create a report, you can deploy this model in production, you can publish and share it. And you can do all this now in Azure. The step where you look at analyzing data and you're creating this model, you can do this in Azure Machine Learning. You can deploy these models in production from Azure Machine Learning. From one click, you can publish your model as a web service where you can then call it from any number of external sources, be it C, C#. You can call it directly from Excel. And you can publish and share it in the same way. So to talk about a real-world example is the traffic fatality analysis. In 2016, the White House put out a call to action. They noticed that between 2014 and 2015, traffic fatalities had increased pretty dramatically, and they put out a call to the industry to try and figure out why has this occurred, or just what's going on, why have traffic fatalities increased after what looked to be a decline. Can we get some information on that? One of my colleagues, Ted Malone, he downloaded the data, loaded it into Azure, used some of our tools, and what I'm going to show you is what he ended up coming up with. This is a huge eye chart, but this is basically the Microsoft Cloud data platform pieces. From an on-prem standpoint, you're going to start with SQL Server. You've got the database engine, and in that database engine, you've got the ability to handle relational data, JSON data, spatial, full text, binary, image, file table, file stream. You can do in-memory. You can do an in-memory OLTP as well as an in-memory column store, which is a highly compressed construct, really good for data warehousing. You can speed up queries based on the way the information is stored and compressed. Ultimately, you've got row-level security, transparent data encryption. You've got all the encryption you need, all the security. And you can deploy this both in physical as well as virtual. I'm sorry. From a BI and advanced analytics perspective, you've got analysis services on-prem. You've got reporting services, both native and SharePoint integrated, and R services. In SQL Server 2016, we embedded R, the ability to run enterprise R services directly in the database. So now instead of having to actually move the data out into a separate server, do some analysis, and then move it back to a third server to do reporting on that, you can run all that directly in the database. And we've got data warehousing, and we've got appliances on-prem that'll do massively parallel processing. In the cloud, we've got the exact same thing. You can do SQL Server in an Azure virtual machine, and you're going to get the exact same functionality that you'd have in SQL Server on-prem. We also have an Azure SQL database, which has 99% of the same functionality as SQL Server in a VM, except you don't have to manage the virtual machine itself. You don't have to manage the operating system. If you just need a database and don't need to take advantage of any instance or environment level parameters, Azure SQL Database will be a good option for you. We've got DocumentDB, which is a MongoDB-like platform as a service component. We've got Redis Cache. We've got Azure HD Insight, which is a platform as a service component, instantiation of Hadoop. So we've got all these capabilities, and what my colleague did was he took the data, ran it through Azure HD Insight to run MapReduce jobs against the data. He then did some more processing and ultimately pushed it into Power BI. And I'll show you what he got out of it. When you load a data set into Power BI, what it initially does, you have the option to create quick insights. And quick insights are actually really cool in that in the background, once you load it into Power BI, the service, what it does is it looks at your data. It looks at the relationships between the data, and it pulls out any anomalies that it sees. So without you having to do anything, if you get a data set and someone says, what's interesting about this data, and you can't just derive it looking at columns of information. If you load it into Azure and perform quick insights, this is what it pulled out automatically. Fatal injury has a relatively steady percent of total RUR, URB. You know, it looks, California has noticeably more, you know, in a clean data set, you'd know what this column was, but these are just things that it pulls out that you can look at. There's a correlation between V total in persons, and not tested for drugs accounts for the majority of V total. Now, V total has a real world complement. I'm not sure what it is. Ted would have to. Ted would know because Ted loaded the data. But these represent real tables, real columns, real information, and you know, provided you formatted your data accordingly, you'd really be able to pull out these quick insights. And this is kind of what he developed. If you were to look at this on-prem in the Power BI tool, it's the exact same. It looks the exact same way, but what he determined was that although it looked like traffic fatalities spiked and it looked like there had been a reversal of the recent downward trend, if you look at the trend analysis, traffic fatalities were actually always increasing. Now, sure, there was a spike, but the overall trend was going up regardless. You can look at the total fatalities, you can look at the number of impaired fatalities, the distracted fatalities, the weather fatalities, and then just some interesting things about total fatalities by holiday. You know, New Year's Day, that's a pretty common one. You know, if you think logically, people are drunk on New Year's Eve, there'd be more fatalities there. But Labor Day, you know, who would think that there'd be more traffic fatalities on Labor Day? And I guess and Mother's Day. Well, you figure a lot of people take their mothers out for lunch, for dinner. They might get drinks at dinner, and they're driving home impaired. You know, Halloween, that's fairly common. But Father, you know, and this is all the information that you just derive directly out of the data. You know, if you look at impaired fatalities by holiday, again, New Year's Day, but daylight savings time, the ending of daylight savings time. You know, the start of daylight savings time. Again, Father's Day. So, you know, if you look at total fatalities by hour of day, Saturday and Sunday are the total fatalities by day of week. So, you know, you can kind of get a sense that on the ending of daylight savings time, if it's a Saturday, you know, stay home. And, you know, stay out of Texas. Although Texas just has more people. You know, Texas and California makes sense, but Florida, North Carolina doesn't, you know, these are all the sorts of things that you can get just directly from the data. And I'll actually show you this live so you can explore the data further. But again, you know, you can look at percentage of fatalities, and these are all just analysis that he did once he got the data into Power BI. To create these slices of the data is really simple. You know, the hardest part of this is loading the data and getting and creating the data model. But from there to create the visualizations, to split this out by month, by year, by state, you know, all that's just part of using the tool. Again, you can look at weather factors. You know, all this information is stored. And one thing that he discovered was that some of the data was wrong. You know, when he first ran through the data, and again, you generate these reports, and he looked, and it said that there was never an accident on a cloudy day in Virginia. And, you know, he knew automatically that can't be right. But he analyzed police reports, and you find out that police reports aren't always accurate. You know, while there may be a space for weather, they don't always fill in the weather. So what he then did was he added in weather data. You know, he linked in weather data from NOAA based on where the accident occurred, their weather stations. So he was able to link together the weather so to get a really accurate account of what the weather conditions were. You know, whether that the blowing snow would be something that a police officer actually put in, but sun, rain, all that are things that he was able to pull from Noah. You can look at the sex of the driver. Again, just more information that you can pull once you've got the data in the Power BI and you start slicing and dicing it. Distracted driving comes out really clearly. The biggest traffic spike in 50 years, blame apps. Is it that accurate? He was able to pull out what the actual causes were, and they're not necessarily what you think ostensibly. But distracted driving is a pretty big factor. This talks about fatalities by vehicle type, driver age, total fatalities by year. Looked and did not see. That's not necessarily distracted. That's just pure driver error. Distracted inattention still pretty big, but lost in thought. That's not necessarily, you're not looking at an app, you're just daydreaming. There are all sorts of reasons why traffic fatalities occur, but the conventional wisdom wasn't always correct in this case. He's able to look at spatial analysis, where you can look at an accident location, and this closely tracks with where the major highways are. But again, all this is just once the information stored in Azure, once the information stored in Power BI, you can slice and dice it. And you can also embed the actual accident details. So instead of just getting visualizations, you can have both visualizations as well as the detailed data, and you can filter and sort and get down to the actual accident level itself. And I can show you this running live. I think I can. So again, the way that Power BI works is you first create a report. And that report, you first bring in the data. And if you think back to that section where we talked about a data science project, you first have to get the data in. Power BI is really good at not just pulling in data from disparate sources, but linking that data together. So without necessarily needing to know structured query language and know how to do an inner and an outer join, through a drag and drop, you can really easily link together disparate data sources. It doesn't have to be all SQL Server, although we prefer if it were, but you can link together SQL Server, Oracle, DB2, and then a web service. And provided there are keys that can correlate that data together, you can just drag and drop and link that data together. Once you've linked that data together and loaded it into the service, you can create a report. And once you've created a report, you can surface elements of that report in a dashboard. So this dashboard is a single pane of glass that you can use to bring up disparate elements of individual reports. So if I were to click on this, and there's also natural query language, where instead of having to, again, type in a SQL query, there's some examples here, but how many total fatalities by state and year? And I could have typed this in, or I could just click on it, but it looks at the data, it looks at your data model, and figures out what the query that needs to be run to represent that question that's written in plain English. Some of the other ones, impaired analysis by state. And it goes out and finds the visualizations that are already in your report and presents them to you without you having to actually type in a true query. So once you've built this report and you've exposed these elements to the dashboard, if we wanted to drill into this, this brings you to the actual report where you've got far more information, far more detailed data, you've got report tabs where, you can look at the overall analysis, impaired analysis by state, weather analysis. So you could say how many accidents on a clear day at 5 p.m. And you quickly say on a clear day, 5 p.m., there were 8,443 traffic fatalities. This is sorting a lot of data, and it's just quickly being able to slice and dice that and bring up these answers. And as you can see, once you click off it, it just goes back. So on a clear day at 5 p.m., there were 1,006 distracted fatalities. You can look at the vehicle type. Four-door sedan, how many motorcycle fatalities were there in the rain? These are the sorts of things you can pull out. You can look at state detail. And the way in which you'd expose these on a dashboard is you just mouse over it and you can pin that visual. Provided, if I could pin it, it would ultimately show up on this dashboard. Any questions on this?
Ask Ted if he's got per capita data. That's per capita is the way you're showing Texas, Florida, and California. Per capita would matter from a data science perspective.
Right. Let's see. Hold on. If we look at.
I think birth order would matter on Mother's or Father's Day.
If we go in and you're looking at state detail analysis, does he have per capita? No, not really. Yeah, you're right. He's just got totals, but true. Per capita as it relates to state population would give you more information in.
Yeah, what's going on?
Right. Exactly. You.
How difficult is it to tie together? Like, is it algorithms that tie together some of the statistics? For instance, this is what was asked: North Carolina per capita, birth order. If you had that information.
If you had that information, I don't have Power BI Desktop on here, but I can express to you how easy it is, provided you have keys that'll relate the data. Again, because that's a key. But let's say you've got the information on traffic fatalities. You've got a column for state, and then you want to correlate that to total populations of. You could either go to a web service and pull in the total population, and then in Power BI, what that'll be represented as, it'll look like a table in a data model.
Just like you did with weather, right?
Exactly. In the same way that you link in the weather, all you really need is a key in common. And it doesn't have to be named the same, and you're basically just creating a join. But it's a drag and drop join that's really trivial to do.
Well, I mean, if you're trying to explain traffic fatalities, the logical thing to do is to call R and run a regression on traffic fatalities.
He's
As a function of population density in the county, weather status from the time you're doing that.
as part of Power BI, you do actually have the ability to do R visuals as well. Power BI ships with, I think, 27 default visualizations that you can use to create, charts and reports and things of that sort. But one of those visualization types is an R visual. So in that R visual, you can write your custom R code. Again, there are some slight limitations in that if you're using a really custom library that we don't have running on the server itself, you're bound by the libraries that are installed on the Power BI service. But you could totally do that. Or you could there are other ways you could do it as well. Like because you can run R in the database, you could use SQL Server reporting services, create that R visual, and then you can pin that R visual from SSRS to a Power BI dashboard as well. And then once you click on that tile on the Power BI dashboard, it can, provided you have the rights, you'd be able to drill down into the SSRS report as well. But these are our visuals. These three are our visuals as well as that one. And outside of the 27 or so that come standard, there are also user-submitted custom visuals. So there's a pretty robust user community who submit their own visualizations as well that you can download and install. And there are more than that on GitHub as well. There's an SDK if you wanted to create your own.
So you can pretty much connect the different databases as you mentioned, right? The Oracle SQL all together and the Power BI will be able to read it at the same time, right?
Yes. You basically, once you, there are two different ways in which you can connect to external data sources. There are, and this is based, and it depends on what the data source are, but there are sources you can connect to live, where it's going to automatically, every time you click, it's going to make a call out to that database and refresh that information. Or you can do scheduled refreshes. And I know that Oracle, you can do either or, and with SQL Server, you can do either or, but there are some limitations based on that data source. But once you've, provided you are doing a scheduled refresh, you can pull them in and connect all sorts of disparate data sources, as long as they have keys that make sense to connect.
What about
The pricing, we are talking about Power BI Gov, right? Or yes, Power BI Desktop is 100% free. The output from that is a .pbix file, and provided someone has Power BI Desktop, you can share that PBIX with them, and everybody can run it for free. You need the desktop in order to actually build anything. Alternately, within the next, I'd say 4 months, you'll be able to deploy the reports. And this is a Power BI report with all the tabs. You'll be able to deploy this report the way it looks here. You'll be able to deploy it to SQL Server reporting services.
Let me advertise. Just go to powerbi.microsoft.com, download the desktop. It's free. It's a terrific product, even if you did have to pay for it.
Yes, but it is 100% free. Right, exactly. I will give you the mic to repeat that. Alternately, there's a freemium version. There's a freemium model if you're running in the commercial world. If you're running in Power BI Government, there is no, all the users are power users. But if we look at the list price based on the website, for the free users, it is 100% free. You're limited by the size of the dashboard you want to upload.
You're making your money by paying for the publishing service. The development tool is free. Power BI on the server.
Even the publishing for a small, for let's say a personal user, the publishing is free as well.
Yeah,
If
the little one.
right.
If you need integrate.
If you want to integrate it and let's say you want a live connection or you want to be able to refresh more than I think 4 times a day, the pro version list price is $9.99 per user per month.
I'll still help you advertise. And compared to their main competitor, Tableau, this is a hell of a deal.
He said it, not he. Right. I would not have brought that up, but since he did, yeah, it's $120 per user per year. Now, and that's the list price. That's on the website. If you have an enterprise agreement or you have 3,000 plus users, It's all negotiable. Everything's negotiable. So, any other questions? But yeah, if you're used to using, say, like traditionally, Excel has been our data analysis tool. You know, and most people are using Excel. The issue with Excel was that Excel 2013 came out, and we released these Power plugins that were really powerful that enabled you to do some really cool analytics. However, the issue that precipitated the need for Power BI is that no one's going to upgrade their Office suite every month or every year or, you know, at any real regular cadence. And business intelligence tools typically get released, you know, new enhancements come to Power BI every single month. There's a new version of Power BI Desktop. You don't have to install it, but we release one every single month. And, you know, when you looked at, if people are looking at Excel 2007 versus a competitor's 2016 product, it just doesn't hold up well. So that was why we created Power BI Desktop and the service as well. But again, the desktop is 100% free. You can use it and get started analyzing information. But if you want to publish it and you want to take advantage of some of the features of the service, like the dashboard, and again, you can create a report, but let's say you've got subject matter experts who, in finance, he creates a report. Operations creates a report. Someone else creates another report. And you've got your upper-level management who want to see all that on a single pane of glass. That's where you need the service, because you can surface up elements from each of those individual reports on one central dashboard. That's a real plus of the service. That and natural language query. That's something that you really need the power of the cloud to take full advantage of.
Just to confirm, so this seems mostly batch-oriented, right? So you're analyzing a mostly static data set, not live streaming analytics, where this is going to update every 5 seconds on a massive amount of data stream, or am I?
That's just no. I'm not going to say you're wrong, but but
Can you repeat the question?
the question was, is this primarily for static batch information? And the answer is no. If we go out to favorites, you can totally take advantage of streaming information. This is the SR 520 bridge in Seattle, and a lot of people take it to commute from the. It's a main bridge connecting the city of Seattle with the with the suburbs. So if you look at it, this is live streaming from sensors that have been put on that bridge. So you can look at the average speed. You can look at the average speed by number of cars. You can look at cars by toll amount. You can look at the toll revenue, and this is streaming. You know, you can most certainly take advantage of streaming information and have it update as it occurs.
But
Yeah, if you look
to be fair to the gentleman's question, there would need to be a back end that was doing that database aggregation. Power BI is a data visualization and reporting tool. So if you've got something streaming that's running 1 million transactions a minute, something's got to get that up to an average in order for Power BI to display
And what
it.
we would suggest is Azure Stream Analytics to process that stream.
Which would be one of among many possible, yeah.
That's what we would suggest, but yeah, there are other ways to take advantage of that streaming. But yeah, Power BI can totally accept streaming information. And I would say batch information is probably not the way most people use it. Most people use it for information that's changing daily, hourly, you know, things of that sort, where they're going to come. And because, again, we've got that refresh model where you've got live connection. So on a live connection, again, every time you pull up the dashboard, it's going to be pulling directly from the source databases. But even in the refresh model, you can refresh. I think it refreshes up to 8 times a day. So, you know, the information is definitely changing. I wouldn't. If you just had static information that you wanted to analyze, there's probably other ways you could do that. Reporting services might be a good use case for that. But Power BI really shines with streaming information as well. And from a certification standpoint, the Power BI public commercial is at a FedRAMP moderate, and Power BI Gov is a FedRAMP high.